Next up, we're going to look at the idea of calculating some probabilities based off of sampling. We've seen the idea in example 1 in a few of our previous videos, and we're going to take it one step farther. Once again, it says suppose a college has a total of exactly 10,000 students, and 25% of the students live less than 5 miles from campus. We're planning a random sample of 100 people without replacement. This time I want to know what is the probability of observing a sample proportion of 30% or larger. In the previous video, video 5, we just saw that the conditions of the central limit theorem are met because we had a random sample. We had 25 expected successes and 75 expected failures. So because this central limit theorem was met, that means our sampling distribution is approximately normal. It's this nice bell-shaped curve. I could take a sample of 100 students from this college, and I expect to get pretty close to 25% as long as my sampling is done correctly, but I'm not going to get 25% every time. We've seen from the standard error that it could be as low as 20% or so, could be as high as 30% or so typically. So I want to know what is the probability that the sample proportion is 30% or larger. So we're looking at 0.30 and above, all the way up the normal distribution. So because this is a probability on a normal curve, this is a throwback to chapter 6. I'm going to use the normal CDF function in my calculator. My lower bound where my shading starts is 0.30. Theoretically, this normal distribution goes all the way up to infinity, so that would be E99. Some instructors say you stop at 100%, so the max is 1. We're so far off from that that it's not going to make an impact on our answer when we round to 4 places. I prefer to be consistent and go to E99. My mean, the number in the middle, is P, which is 0.25. And I don't have a standard deviation given to me like I did in back chapter 6. So instead, I use the standard error formula, which is P, or 0.25, parentheses 1 minus P, that same 0.25, all over N, which is your sample size of 100. And you just type this in all at once in your calculator as it is. So to get that normal CDF, recall you hit second in VARs, it's number 2. I'm going to go with 0.30 as my lower bound, E99 as my upper bound, 0.25 as my mean, and then that standard error, just type it in all at once. Don't calculate it ahead of time because that little bit of rounding can throw the answer off just enough in my stat lab that it counts it incorrectly. So just type it in all at once. So second x squared to grab that square root, 0.25, parentheses 1 minus 0.25. Close those up and then divide by the sample size of 100. And so that gives me 0.1241. Think about it as 12.41%. So I would expect about 12 or 13% of my samples to be at 30% or above. You can see another example. In example 2, we saw this situation in the previous video as well. Once again, according to the Regional Bar Association, approximately 66% of the people who take the bar exam to practice law in the region actually pass the exam. We want to find the approximate probability that at least 72% of 200 randomly sampled people taking the bar will pass. Once again, we know the central limit theorem is met, which is going to allow us to use an approximate normal distribution. My P of 0.66 is what's in the middle. That's what the Regional Bar Association reports. That's our standard. We want to know what's the probability that we can get 72% or more of 200 randomly sampled people to pass the bar. So we're looking at this upper region once again. At least 72%, at least means that number and more. Because this is a probability question from an approximately normal curve, I'm going to go that normal CDF route once again. Normal CDF is back in Chapter 7. My lower bound will be 0.72. My upper bound is going to go to E99. My mean comes from the middle, that's 0.66. And again, we use the standard error, so it'll be 0.66 parentheses 1 minus 0.66 all over 200. Standard error is the square root of P parentheses 1 minus P all over N, and that's in a previous video. I'll just enter this in all at once on my calculator. Second bars, number 2, and I'll type this in. I hit enter, and I get 0.0366 if you take that to 4 places, or you could say it's 3.66%. So the typical number is 0.66 or 66%. We can see it's a very slim chance that you could get 72% from a group of 200 to pass this exam. Let's go through one more example similar to these two. Example 3 says we have a true-false test with 50 questions. On this particular test, you don't have to get a 70 or above to pass, but a passing grade is a 67. 67% or more correct will help you pass the test. So what is the probability that a person will guess correctly on just one true-false question? There's only one correct answer. It's either true or false. So you have a 50-50 shot. So it's a 50% chance that you can get the question correct by guessing. Which on part B means there is a 50% chance, 50% probability that the person will guess incorrectly on one question. So what this tells me is I would expect you to get about half of your true-false questions right if you're just to go through and randomly guess. Not even read the questions, but just guess true, false, true, true, false. You should have a 50-50 shot, or you should average about a 50 on that test. It says on part C, using a normal approximation. So we don't have to check the central limit theorem here. We're assuming that it's normal. Find the probability of the person who guesses on every question will pass the test. So what's typical is that you'll get 50% of these right. I want the probability that someone will pass, which means they need to get a 67 or above. A 68 would pass, a 70 would pass, a 75 would pass, an 80 would pass. So what's the probability a person could pass a true-false test that's 50 questions just by guessing? because this is probability from that normal approximation, I'm going to use that normal CDF feature. 0.67, E99, 0.50 is my mean from the middle, and then square root of 0.50, parentheses 1 minus 0.50, all over n. My sample size is the 50 questions from this test. So to enter that in, and we get 0.0081. So you have less than a 1% chance of getting a passing grade if you just go through and guess on all 50 questions. So that's why it's important to study, to have an idea of what you're going to be tested on before you go into the test. Just a quick note before we close this video, if your answers aren't matching these as you're typing these in, a common mistake is not to close the parentheses in the standard error. So make sure you have parentheses 1 minus 0.50, close those up, just like we did in the previous normal CDFs as well.